This is the your turn number 2 in section 2.2. So we want to determine the square root function of this quadratic. So the first thing we want to do is, what is the vertex of this quadratic, what is the y-intercept, and what are the x-intercepts. Remember, the x-intercepts is when y is 0, and this is going to be part of our invariant points, which helps us to distinguish the graph of the square root function. So I'm just going to go down to the bottom of it to do the workings. So we have y equals -3 over 2 x squared plus 3x plus 9 over 2. So to find the vertex, we're going to use the vertex formula -b over 2a. So when you use the -b over 2a, you're going to have -b, which is -3, 2 times -3 over 2, which would give us 2 negatives as a positive. We'll get 3 divided by the 2's cancel, 3 divided by 3, which is 1. To get the y-coordinate that goes along with this x-coordinate, we substitute it back in. So when we substitute 1 back into the function, we'll get -3 over 2, 1 squared, plus 3, plus 9 over 2. And this will give us a value of 6. So we know that the vertex is 1, 6. To find the y-intercept, we let x be 0. Again, in the equation, we're left with 9 over 2, which is 4.5. To get the x-intercepts, we let y be 0, and we're going to factor if we can. If not, we'll use the quadratic formula. So when we have 0 equals 3 over 2 x squared plus 3x plus 9 over 2, I'm going to multiply the whole equation by -2 so that I don't have to worry about those fractions. So I'm going to get 3x squared minus 6x minus 9. I'm going to divide by 3 because it's a common factor, so I'll get x squared minus 2x minus 3. So my two factors, using product and sum, would be x subtract 3, x plus 1. So my x-intercepts are 3 and -1. Now remember, these are part of my invariant points. So I'm going to go back and I'll sketch those values. So 3 and -1 are my x-intercepts. I know 4.5 is my y-intercept, and my vertex was at 1 and 6. The parabola opens down because the leading coefficient was negative. So open downward. All right, so I'll try to graph this a little bit with my tablet, try to make sure everything goes through the points. Okay, so I know this is my original function. Now, when I go and sketch the square root of this function, I know y values that are negative are not going to work, so I eliminate everything below. I know that I have to find the other invariant point. We already found it when y was 0. Those were our x-intercepts, but now I have to find out where y is 1. I can look at the graph, but again, the graph is just an estimate, so I'm going to do it algebraically. So y is 1, so I'm going to set 1 equal to the function again. So I'm just going to write that down. I'm going to multiply everything again by -2 just to get rid of those fractions. So I get -2 equals -3x squared plus 6x plus 9. -2, so sorry, that'd be positive, negative, negative, so that. So then I'm going to bring the 2 over, so I'm going to get 3x squared, subtract 6x, subtract 7 equals 0. Now again, I cannot factor this, so I do have to use the quadratic formula, which we did in the previous example. I'm just going to skip a step and tell you what you're supposed to get. 6 plus or minus 120 over 6. Again, you can use your calculator for this. You'll get 2.8 and negative 0.8. So when you go back up, you know that 2.8 is where y is 1. So my graph is a little bit off, but that's okay. We know that negative 0.8 is where y is 1. And then we're going to sketch our graph. Now remember that we do have a vertex here, which means that vertex is also going to change on our square root function. So what was 0, 6 is now going to become 0 root 6. So keep that in mind, that our vertex will get a little bit lower, which is a little bit above 2. So I know that when the graph comes above it, it will eventually reach that lower vertex point. So remember, that does reach at root 6. So this is my square root function. And I use the invariant points to help me. I use that vertex to help me. And then I'm going to get domain and range. So the domain, if you look, is going to be in between these two x-intercepts, and the range is going to start at 0, but it is going to reach this part of the vertex from the original when you square root it. So remember, that is root 6. So when you do your domain, you're going to get negative 1 is less than or equal to x, which is less than or equal to 3. You can write that using brackets. The range is between 0 and root 6, and if you like, you can use your interval notation here as well.